In this example problem, we're going to be looking at a convex mirror. So what I've drawn here is I've drawn a convex mirror, which is about the exact same shape as a concave mirror. It is. The only difference is where the polished end is. So the smooth part is going to be the polished part, and the jagged part is going to be the unpolished part. Here's going to be my object. All right, so light's going to come from my object and go to the mirror. All right, let's read the problem now. An object is placed 30 centimeters in front of a convex mirror having a radius of curvature of 40 centimeters. Now, the focal length, remember the focal length, is going to be equal to 1/2 r upon 2 because it's convex. And this is going to be 40 upon 2, which is going to be equal to a negative 20 centimeters. So we'll go 20 centimeters this way. Now, I'm going to erase this so it doesn't get in my way, but that's how you come up with the focal length. The focal length is going to be half the radius of curvature. And for the first ray, we're going to use, this is going to be ray 1. And I'm going to draw it as well as I can. It's going to go parallel to, along the principal axis. And I'm going to draw this as a dashed line because it's going to be virtual, all right? So if I draw this, so it goes parallel to the principal axis, and then it's going to be dashed. Then so it goes parallel to the principal axis, and then it passes through the focal length. So it's going to pass through the focal length. Now, the next one is going to be, it is going to be from, this is going to be ray 2. It is going to go from the object, and then it's going to, and it has to be angled such that, and it's going to go from the axes, it has to be directed towards the focal point, right? And then it's going to go parallel to the principal axis. So I got to see if I can, I should use a ruler to help me do this. So I'm going to do this. So this is going to be a solid line right to there. And then from here, once it hits that mirror, it's going to be parallel to the principal axis as such. And that's going to be ray 2. That's going to be our ray 2. And where these two intersect, so we can continue that, is going to be where the image occurs. It's going to be where the image occurs. Now, it can't go directly to the focal point simply because it's going to run into the mirror. And this is going to be our image. And so the image is going to be, it's going to be virtual because it's going to be behind the polished part of the mirror. So it won't be able to be displayed upon a screen. It's going to be upright. It's going to be upright. And as we can see, it's going to be smaller than the actual object. Now, what's going to happen here, what happens here on the polished side is that once the light hits this mirror, it's actually going to go in this direction. That's going to be the reflected beam. So this is the incident beam. This is now the reflected beam. If we look at trace number 2, this is the incident beam. And it's going to get reflected back this way. All right. Now you can notice that these two rays are never going to cross no matter what. The only place they cross is behind the mirror. Thus, that's what makes it a virtual image as opposed to a real image. If they were to cross on this side of the mirror, it would be a real image, but it's a virtual image. All convex mirrors are going to form virtual images.